Welcome to the session on modelling in mechanics, working with vectors. The objectives for this session are to understand the difference between scalar and vector quantities and carry out related exercises. A vector is a quantity with both magnitude and direction. Let's take a look at an example. The column vector A equals 3, 4, as shown in the diagram, is an example of a vector. We can give further examples of vector quantities. So, for example, displacement is described as the distance in a given direction, and its SI unit is meters. Velocity is the rate of change of displacement. Its SI unit is meters per second. Acceleration is the rate of change of velocity. This is measured in meters per second squared. And finally, weight or force is described by magnitude, direction, and point of application. Of course, we do use abbreviations. Meters represents M, seconds is represented by S, kilograms is represented by kg, and Newton by capital N. A scalar has only magnitude. So if we consider our vector A equals 3, 4, we can put it in scalar form by finding its size. So an example of the magnitude of this vector would be mod A equals square root 3 squared plus 4 squared, which equals 5. Of course, we've applied Pythagoras. We're now going to take a look at some examples of scalar quantities. Some examples include distance, which is a measure of length. The SI unit for this is, of course, meters. We also have speed. It tells you how fast a body moves. This is measured in meters per second. Again, these are all SI units. We also have time. This is another example of a scalar quantity. And, of course, we know what time is. We're looking at how long an event takes, or ongoing events take. And time is measured in seconds. And finally, we have mass, which is the quantity of matter in an object. This is measured in kilograms. So to summarize, a vector has magnitude and direction, and a scalar has only magnitude. Let's now take a look at an example. We're going to consider moving towards the right-hand side, the positive direction. We're now going to look at how velocity, acceleration, and speed interact with one another. So let's consider part A first. We have that velocity is greater than 0 and acceleration is greater than 0. So they're both positive. Therefore, speed is also positive. So to sum up, the particle is moving to the right and its speed is increasing. And now for part B. We have that velocity is greater than 0 and acceleration is less than 0. Therefore, velocity is positive and acceleration is negative. And therefore speed is negative, which implies that it is decreasing. We also refer to this as deceleration, retardation, or slowing down. So to sum up, the particle is moving to the right and its speed is decreasing. And now for part C. We have that the velocity is negative and the acceleration is negative. Therefore, the speed is positive. In other words, it's increasing. So to sum up, the particle is moving to the left and its speed is increasing. And finally, for part D, we have that the velocity is negative and the acceleration is positive. Therefore, the speed is negative. Again, this is referred to as deceleration, retardation, or slowing down. And it implies that speed is decreasing. So to sum up, the particle is moving to the left and its speed is decreasing. Here's a summary of the results. We will now take a look at unit vectors. A unit vector can be used to represent vectors in 2 dimensions. It has length 1. Unit vectors along the x and y axes are denoted by I and j respectively. So I equals 1, 0 and j equals 0, 1. Here's I in the diagram and here's j. We're now going to consider a 2-dimensional vector, pi plus qj. So here's our vector, AC. In the I direction, we have that AB, as shown, is equal to 3I, and BC in the diagram as shown is equal to 2j. So by the triangle law of addition, we have that AC equals AB plus BC, which is equal to 3I plus 2j. So here's AC, here's AB, which is 3I, and here's BC, which is 2j. And of course, AC completely is equal to 3I plus 2j. In notation, for any 2-dimensional vector, we write PQ as shown as PI plus QJ. So let's recap a few things and add a few more. A vector has both magnitude and direction. For the vector A equals xi plus yj, or written in vector form as xy, the magnitude of a vector is mod A equals square root of x squared plus y squared. We've applied Pythagoras here. The distance is the magnitude of the displacement vector, and speed is the magnitude of the velocity vector. Let's now take a look at an example. Given that the velocity of a particle is v equals 3I plus 2j meters per second, find the speed of the particle and find the angle, the direction of motion the particle makes with the unit vector I. Here we have a little illustration of the vector v. So let's have a go at part A first. In the x direction, v has a value of 3, and in the y direction, v has a value of 2. So let's solve this. The speed of the particle, if we apply Pythagoras, is square root of 3 squared plus 2 squared. Here's 3, and here's 2. To give us square root of 13. And now for part B. We are required to find the angle, the direction of motion the particle makes with the unit vector I. Let's call this angle theta, as shown in the diagram. Now v of course equals 3I plus 2j, so therefore we apply the tan formula. So tan theta equals opposite over adjacent, and plugging in the relevant values gives us tan theta equals 2 over 3. So here's theta, here's the opposite, which is 2, and here's the adjacent side to theta, which is equal to 3. So we have that theta equals tan inverse 2 over 3. Which equals 33.7 degrees. We're now going to look at adding vectors. Suppose AB and BC are vectors, then AC equals AB plus BC. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. Suppose a boy walks from A to B and then from B to C. If AB equals 8, 4 and BC equals -3, -8, find mod AC and the total distance the boy has walked from A to C. So let's solve. We're first going to draw a sketch. AB is given as shown. Here's AB equals 8, 4. And here's BC equals -3, -8. And you can see these in the diagram. AC is joined. We have that AC equals AB plus BC from the law given. So this equals 8, 4 plus -3, -8. Which gives us 5 minus 4. So AC equals 5 minus 4. So the length of AC, or the magnitude, when we apply a Pythagoras, is equal to square root of 5 squared plus -4 squared. Which equals square root of 41. And so we have found mod AC. We are also required to find the total distance the boy has walked from A to C. Of course, mod AC was the net distance. So if we're trying to find the total distance the boy has travelled, we're going to add the distance from A to B to the distance from B to C. In other words, mod 8, 4 plus mod -3, -8 as shown. And using Pythagoras gives us square root of 8 squared plus 4 squared plus the square root of -3 squared plus -8 squared. Which equals square root of 80 plus square root of 73. And then this can be tidied up. To give 4 root 10 plus 3 root 7. This brings us to the end of this session. If you have understood its contents, you should be able to understand the difference between scalar and vector quantities and complete related exercises. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.